Let's start with the family tree. GPT-1 in 2018 with 117 million parameters, a modest beginning that proved unsupervised pre-training could work. GPT-2 in 2019 with 1.5 billion parameters, 10 times larger, showing zero-shot task transfer was possible. Then came GPT-3 in 2020 with 175 billion parameters, over 100 times larger than GPT-2. This wasn't just scaling, it was a phased transition. The model could learn from just a few examples. GPT-4 in 2023 with estimated at 1.7 trillion parameters, another 10 times jump, adding vision capabilities and dramatically improved reasoning. That's 14,500 times growth in 5 years. But the real story isn't the numbers, it's the revolutionary capabilities that emerged at each scale. GPT-1 laid the foundation. 12 transformer layers, 768 hidden dimensions, 12 attention heads. Modest by today's standards, but revolutionary in approach. The key innovation: decoder-only architecture with causal masking. See this attention matrix? Red cells are masked. The model can only attend to previous positions. This forces left-to-right generation, perfect for language modeling. GPT-1 introduced two-stage training. First, unsupervised pre-training on books, learning language patterns without any labels. Then, supervised fine-tuning on specific tasks. This transfer learning approach was the breakthrough. One model could be adapted to many tasks instead of training from scratch each time. The genius of unsupervised pre-training. Learn from raw text without labels. Given the cat sat on the predict the next word. The internet provides infinite training data. The model sees math follows 45% of the time, floor 22%, table 18%. It's learning probability distributions, grammar, facts, and reasoning patterns, all from predicting the next token. Train on billions of tokens from books and web text. No human annotation needed. The model discovers language structure on its own. This simple objective, predict the next word, somehow teaches the model to understand and generate human language. GPT-2 brought massive improvements, 10 times larger at 1.5 billion parameters, 48 layers deep, 1,600 hidden dimensions. What the real revolution? Zero-shot task transfer. No fine-tuning needed. Watch this. For translation, just prompt translate to French. The cat is black and it responds le chat est noir. For summarization, prompt summarize, followed by text. For Q&A, just ask questions directly. The model learned these tasks implicitly during pre-training. No task-specific training required. This is so powerful that OpenAI initially deemed it too dangerous to release, fearing misuse for disinformation. The full model was released gradually over months. GPT-3, the scale revolution, 175 billion parameters, 116 times larger than GPT-2. This wasn't incremental improvement, it was a qualitative leap. The breakthrough in context learning. Give the model a few examples and it recognizes the pattern. Watch, good right arrow bueno, bad right arrow malo, cat right arrow gato, dog right arrow. The model responds pero. No training, no weight updates. Just pattern recognition from examples. Zero shot needs no examples. One shot uses one example. Few shot uses 2 to 10 examples. The model adapts to new tasks on the fly. This flexibility was unprecedented. One model could do translation, coding, writing, analysis, all without task-specific training. Let's dive deeper into in-context learning. The model recognizes patterns from examples. For sentiment analysis, show examples of tweets labeled positive or negative. Then, ask about a new tweet. The model infers it should classify sentiment. The model understands the task structure from context alone. No explicit instructions needed. Just this works for any task with a clear pattern: classification, translation, question answering, code generation, creative writing. This is remarkable. The model is programming itself through examples. It's meta-learning, learning how to learn new tasks from just a few demonstrations. GPT-4, Multimodal Intelligence, approximately 1.7 trillion parameters, that's 10 times GPT-3. But size isn't the story, it's the capabilities. GPT-4 processes both text and images. Show it a chart and ask, what trend does this show? It responds with detailed analysis. It can read text and images, understand diagrams, analyze visual concepts. The context window expanded to 128,000 tokens, enough for entire books. Reasoning improved dramatically. Hallucinations reduced. It passes professional exams, writes complex code, and maintains consistency over long conversations. This isn't just a chatbot anymore. It's approaching general-purpose intelligence. The most fascinating aspect, emergent abilities, capabilities that appear suddenly at scale, not gradually. Look at these curves. Below certain thresholds, models show near zero performance. Then, suddenly, emergence. Arithmetic emerges around 20 billion parameters. Translation at 10 billion. Complex reasoning at 50 billion. Code generation at 30 billion. These abilities weren't programmed or specifically trained for. They emerged from scale alone. The models develop capabilities their creators didn't anticipate or design. This is the mystery of deep learning. We don't fully understand why these abilities emerge. We just know that at sufficient scale, with sufficient data, intelligence emerges.